All right, hi friends. So we're going to work on section 9.6, which is solving non-linear systems by graphing and algebraically. So 9.6, so non-linear systems. Okay, that just means, hey, we're still going back to systems, but where the two systems would intersect. So one of the first ones we're going to do, and you'll notice that I started off with what is this? You're right, this is a parabola. And I want to see where it will intersect with, what's this? With a line. So let's think about this, a parabola and then a line. Well, let's see, I could maybe not intersect, right? So I could get a no solution. I could have it go through twice, right? Or I could have it hit once right on the vertex, right? Okay, so one of the first ways they tell you about doing this is by graphing. What I don't want to do is graph by hand, just because it's just too, there's too many what ifs, okay? So I'm going to use my handy dandy graphing calculator to see if I can estimate, okay? And here's the thing. So you would go under y equals, you'd put your first equation in, that's your parabola, okay? And your second equation is going to be your line, okay? So does everybody see this? All right, and let's graph. Oh, I'm zoomed in. Oh, poop. All right, so let's see if I can, oh, I can see it. All right, I'm gonna zoom out. There we go. All right, here comes the parabola. And, oh, right there. Look at that. So my guess is that it hits about once. So I would like to know where exactly, let's see if I can estimate. That looks like about -1, 1, 2, 3, 4, maybe -1, -4, maybe. Okay, so here's how you would check, okay? So I'd go to math, not math, sorry, second function table. Now notice that you have two different y values. So remember, your first y value here was your parabola, right? Your second y value here is your line. And we want to see where the two y values are the same. Same x value, both y values. So let's see. I'm not noticing. Remember, my guess was -1, -4, right? Oh, yes. Look at that. Do you see it? -1, -4, -4. That's our point of intersection. Awesome. You know what? You could go back and check that algebraically if we wanted. So y is equal to -1, 2 times -1 squared times 5 times -1 minus 1. And let's see, that would be 2 minus 5 minus 1. Oh yeah, -4. And y is equal to -1 minus 3, which is -4. Yay! That's my point of intersection. I'm going to do a quick sketch and just kind of box it in so I can be like, yeah, that's it. Okay, so do you see where that might not be the best way of doing? Okay, let's try another one. Let's do this one. Y equals -x plus 6. Y is equal to -2x squared minus x plus 3. All right, do you remember where to go? Yep, go back to your y equals. You hit clear. Everybody see all right? Clear on that? Let's put in our new one. It doesn't matter which one you put in as long as you remember which one you're looking at. And this one's going to be negative 2 x squared minus x plus 3. Okay, are you ready? Got it all in? All right, let's hit graph. There's my line. Oh. Do they intersect? No. Oh, well, that's easy. No solution. Again, let's do a quick sketch. So it looks like my line goes like that and my parabola goes like that. And so that's a good way of showing like, hey, they don't intersect. Okay, so how can we do this algebraically so that we can actually see? So let's take those same points. Okay, so we know what the answer is at the top. Let's see if we could figure out how to do this algebraically. Okay, friends? So if I were to do it algebraically, which would be pretty easy to get the right answer, and I wouldn't have to worry about graphing by hand. Now, graphing on the calculator, remember, friends, that you could get decimals here. If I were to do this algebraically, look at, you see how they're both set equal to y? So why can't I set them equal to one another? Okay, so the question is, well, that's great. Once we're set equal, now what? Well, see how this is x squared, right? So wherever the x squared is here, friends, I'm going to kind of move things over to that side. So I'm going to subtract x. I'm also going to add 3, and I'm going to add 3, and that gives me a big fat 0 on that side. Okay, plus 4x plus 4. Okay. Oh, wow. Do you notice something? Well, they all have, I could divide everything by 2. So you know what? Let's do that because life, let's make life easy here. 0 equals x squared plus 2x plus 2. Okay, now you might be like, I'm going to bust out oops, see what I did wrong? This is a -3 or a -1. Yikes. Sorry, friends. Oh boy. Well, I just made a mistake, didn't I? So let's try this again. 2x squared plus 5x minus 1. All right. Minus x plus 3 plus 3. So x is equal to, or 0 is equal to 2x squared plus 4x plus 2. Okay, now divide everything by 2. 0 equals x squared plus 2x plus 1. Okay, can I factor this? Sure. What are my options? I could factor, or I can do the quadratic formula. But what would be easier? Well, I don't know about you, but I really like factoring. So that's my answer, right? So it's not really a positive one, it's a -1, and both of them are the same. Now, am I done? Well, no, I need to get the y value, so plug it into either one of these. This one's really easy. -1 minus 3 was a -4, so my point of intersection was -1, -4. So we're coming full circle, friends. We've come full circle where we've done systems. Now we're coming back and using substitution again, okay, to actually find the point of intersection. Okay, sorry about goofing up there. Again, you have your options. You could factor, or you can do the quadratic formula. Friends, take the easier, okay? I think quadratic formula takes a long time, okay? So make your life easy. All right, how about, let's do this one. Okay, remember this was our no solution. So let's set this equal. Negative x plus 6 equals negative 2x squared minus x plus 3. Okay, so let's see. How about add x? Add x. Whoa, wait a minute. Okay, so hold on. X's go away, plus 3. Oh, hey, I could do, see how this is all by itself? Could I use square roots on this? I totally could, couldn't I? How about I subtract 3? So 3 is equal to negative 2x squared. Okay. Divide by negative 2. I get negative 1.5 x squared. Square root. Oh, I can't. Can't square root a negative. No solution. So see how I got no solution on that? Okay. Now they do have you try elimination on these. So let me show you one by elimination. I don't know if I like this as much, and I'm a big elimination fan. So let's try this one. Okay, now elimination is supposed to be getting rid of something, right? Okay. So the problem here is you have to eliminate something. So this doesn't have an x squared, but this has a 3x and so does this. So if I multiply by a negative 1, okay, but I also don't like that they both have x and y's over here, but whatever. Again, you can decide if you like the substitution that we've been doing or whether you like this part. Okay, do you see what happened? I did negative, negative, and negative. Okay, if I add these together, the y's cancel out, right? This x squared comes down, the 3's go away, and I get plus 6. Now, that is solved by a square root, so I would subtract 6, square root each side, and I get no solution. So you'll have to decide if that is your favorite way of solving that. Now we could go back and we could put that into our calculator and see if they intersect again and double check that. So if I wanted to, I could go back and you know what, they would not intersect. So what do you do? What do you do with decimals? Okay, what do you do with oh, I'm not sure what drawing that is. So what do you do with decimals? So let's take a look at this. Okay, so approximating. Okay, what do you do when you have y is equal to 1/2 x squared plus 3 and y is equal to 3 to the x? Wow, so that's an exponential. Okay, so what do we do? So let's go back to y equals. Let's clear these out. Okay, let's see if we can find. So I'm going to put in 1 divided by 2. I'm going to put in a half just like that. X squared plus 3. Okay, and this is going to be 3 to the x power. Okay, all right, here we go. All right, this is a parabola. This is an exponential growth function. Oh, okay, so I'm hitting right about there. Okay, so I'm going to do a quick, I want to do a quick sketch. So exponential, and then the parabola hits like right there. Now I can look, it looks a little past 1 It looks about 1, 2, 3, maybe 1, 3-ish. All right, let's go to our table. What does our table say? Okay, what does our table say? So second function, okay. Remember, my guess was about 1. Oh, jinkies. I don't really see. Do you? Now, let me do this, okay? I'm going to so I'm going to go back. I want you to do something on your calculator. Want you to go back and go second function, and I want you to hit your window button. See where it says the change in the table is 1? Let's go a little bit more precise and change it to 0.1. And then let's go back to our table and see if we can get anything closer. Let's see. Ooh, no, not quite. Oh, not quite. Are we getting closer? We're getting closer. We're getting closer. Remember, I'm looking for where these two. Wow, we're within. Oh my goodness, look at that. We're within 100th. Look at that. See how close we are? I don't think we're going to be exact, but I think that's going to be the closest. So my guesstimate is 1.2, comma 3.72 is I'm going to guess. Okay. So that would be my best guesstimate. Wow, that is really, really close. Okay. Really, really close. Questions on that? That would be my best way of guesstimating the closest piece. Okay. All right. Thanks, friends.